The exam is
Next Wednesday?
Monday.
Monday?
Yeah.
That's what I said.
That's exciting, right? On Monday afternoon, I believe.
Is it here?
Yeah.
I mean, like, this room?
I actually did not know it was Monday.
Did you do the labs? I mean, not the labs. Yeah.
Yeah, I haven't had a meeting this time. I had an 88, so this final couldn't.
The key thing.
Could be an A. could
See,
be
I need the
something.
labs, that's the thing. And they're
I
like,
just went to the library one week and I stayed till like 8 o'clock. And just,
but see how you, like, but you got them all in your book. To me, it says something, but it wasn't.
and the ones I didn't have, I asked Sabrina for. You should have been, Shannon, you should have been doing those tutorials
I'm about to do them now.
when you had the chance.
Thank you. All I need is to do those ones. My labs. That's my labs. I should be
He's
absent.
probably gonna use
Huh?
He's probably gonna use like the exact same thing. That's what he did for the last time.
But last test, no, it was a little different, wasn't it?
It was like Sabrina said it was exactly the same because she had to.
I hope it's like this little picture.
But this is a lot of
It
math.
is. Okay, for my other test, these are my regular tests, so I ain't gonna complain. Well, I think it's like 60. I should have photocopied it. But do you turn yours in?
What?
This.
Yeah, you didn't sign it over.
I do, but I write down all the answers. So
He didn't add it to the test. It's in a separate.
no. But I gotta study it though. So that's what I do. I rewrite every year. Why you game last night? You didn't do the game last night? You said I do every game.
No. We do Friday, Saturday. I don't know. Because no one wants to cheer during the week.
But y'all do practices in it, right?
Yeah, practice.
Oh, exactly.
It's not longer. It's almost finals time. We're not doing no games or practice, no sleep.
So I do like 10 tutorials. Would it be, I might do that.
It took me so like 2 hours just to do it.
I might have to, this only, like this say, I don't know what the sentence is. It's like 64. It's all the niggas over laughing. It's gonna boost me up. But me and Sunshine was laughing, it was working out. But I don't know
I
what to
mean, if you buy something like this semester, you have next semester.
to do it over.
No, to fix your GPA.
But see,
You
I'm
just
gonna
gotta get like all A's and stuff.
have to redo this math.
If you fail. Not if you fail.
At least
I don't know if you'll join it.
But see, I'm trying to get my, see, all I need is associates here. And I'm going to my bachelor's. So I really needed to transfer for that. So if I get associates. But
I
this,
needed this class to join.
He got
I didn't get the
passed.
Which
Where?
I didn't get the email.
Jazz is
Oh, no?
I thought it was you need to see him like English, like certain class.
Yeah, I thought it was one of these was this class. It's I don't give a fuck.
I'm not sure. I'm not sure.
He does what? This class will be great class. So that's fun. That's the way.
It all depends on where you're taking, like, if you're applying for a program, sometimes they require you of your.
See, I know nursing is serious, so I already know. I'm already.
Yeah, I think generally, I think the other one that I was thinking of was the beach, but there is no change to it yet. Because of that, I know. And we need to get certain.
That's back there. I'm gonna do you.
I'm getting a high C.
And look, I'm putting that.
That makes
I'm
sense.
that. So when
Here,
just last time.
my biggest worry is my work.
You're welcome.
Get tutorial. Good team. The tutorial.
It depends. One of the first ones were 5, and the other ones are.
So these 10. That's
Wait, but we're having tutorials this time, right?
Yeah.
Really?
Yeah, what he said to do. And it's, if you turn this on.
Wait, but this is. Oh, we get to do tutorials?
Yeah.
All of them? But it's everything.
The final exam, we get tutorials, right? Excuse me. Huh?
Professor Young?
Yeah.
With tutorials, we could still, you said we could still do the tutorials to get extra credit?
I didn't say
You said that, you just said
I wasn't here.
Find something.
Oh, I don't know.
Oh.
She's mentioning it, but I
You
wanted to
said
say.
cell 3 we didn't have.
Let us know.
You know what I'm saying, that's, what you said, 10
I know when I heard you just say
You said, why did I say that?
I heard that.
I don't even know what's a wire broke. Or not a whole, most of the antifreeze.
Right, so it's like overheating?
It's not overheating, but it's like, I guess it's the water's not going through. But it's not overheating. It's a little smoky, but it's not
overheat though?
Yes, I'm not using it.
Yeah.
I had it last night.
Yeah, it's on fire.
So when I go to need to buy a new hose and stuff. So these are non.
All right, well, let's go ahead and do this. That's just to make sure everybody's awake. All right. I guess this is our last lecture, and gee, that's a shame, isn't it? It just went by, it was so much fun. You just asked a question about tutorials and stuff. So here's the official announcement. It is an amnesty day here. Amnesty day will last until Friday at midnight. I have put all the quizzes, extra credits, and stuff back up. You can do them and try your best to improve your score from now until Friday at midnight. After that time, they all disappear. That includes all the labs. Please make sure you have everything done, okay? Because these are easy points, and you would hate to miss out on them, right? Right. Any questions? Yeah,
The tutorials, that's all the tutorials, even the ones that we did already, or the ones that
the
we
ones that we've done already, you may,
do them over?
yep, if you like that,
Okay.
as practice for the final exam.
How many points for each one? I mean, how many points for each?
Tutorials, I forgot.
I think, is it because I know the first one were like 5 points, and the
Yeah.
second time they were 10 points.
Yeah, that's gonna be too hard for me to figure out. And since it's a second round, let's just do 5 points
5
each,
points,
okay?
okay.
What chapters is it on for this?
The final exam?
Yeah.
Everything that you've ever learned, starting with the, okay? All right, let's go ahead and run through this exam. Just like the sample, your actual final will have 40 questions, plus it will have an extra credit. So it'll be a total of 205 possible points. Complete the following table. This is straight off of one of the tutorials, density 1, I believe. Mass, volume, and density. We are given mass and we are given a density. Simply need to calculate a volume. We remember that density is mass divided by volume. Therefore, volume is going to be mass divided by density. Simply take our mass divided by our density, and it's 6.67. Any questions? You will be given a periodic table, so you don't have to squint and see the ones here on the side. Again, this is straight off of one of the tutorials. And what you have to do here, as you recall, is to figure out protons, charge, number of neutrons for these various elements and isotopes. For cobalt, we look at our periodic table. Cobalt is down in here somewhere. There it is. Its atomic number is 27. Remember, the atomic number is the number of protons. Now, we are given here that we have 26 electrons. We have 27 protons. Therefore, the charge here is +1. We look over here at our mass number. Remember, the mass number is the sum of protons plus neutrons. So if our mass number is 60, 27 of them are protons, 33 must be neutrons. Same thing over here for potassium.
Wouldn't it be 34?
No, you want to get 60. 27
Oh,
plus
gotcha.
33 is 60. Right.
I was adding the electrons and deletions.
Right. Electron doesn't count. Potassium. Potassium is here in the fourth period, first group. Its atomic number is 19. Therefore, it has 19 protons. Now, let's see. We are given that we have 20 neutrons, 19 protons. That means our mass number, which is the sum, should be 39. If we have 19 electrons and 19 protons, by gosh, they cancel. 19 pluses, 19 minuses, so our charge is 0. Any questions? In the space below, write the chemical formula for nitrogen triiodide. Now, nitrogen and iodine are both nonmetals, aren't they? So this is a molecular compound. That's why we use multipliers here. Very simple. The first element is just nitrogen. And triiodide simply means we have 3 iodines. Nitrogen triiodide is an interesting compound. It is very easy to make, actually, but it's a very, very sensitive contact explosive. You make it in solution, it dries, and all you have to do is basically touch it with a feather, and it will explode. Very interesting compound. All right, we're looking for the chemical symbol. Remember to differentiate chemical symbol from atomic symbol. Atomic symbol, we take the chemical symbol and we put the mass number and the atomic number around it, and the charge is appropriate. For the chemical symbol, we're simply looking at the symbol on the periodic table. Let's see, for an element with 17 protons, this is actually very, very simple. All you have to do is remember that the number of protons is the atomic number. So we look at our periodic table here. For an atomic number is 17. Oh, there it is. And this is simply chlorine. Any questions? See how simple all this old stuff is now? All right, let's fast forward to chapter 12, I believe it is. Ozone layer in the stratosphere is important to life on Earth because, and I believe that your copy of the exam has this UVA, that should be B, so you might change that. That's a mistake. What do we know about ozone? It absorbs high energy UVB, very effective at removing pollutants, stimulates thunderstorm, enabling the water cycle. Well, if we recall, the ozone layer lives in the stratosphere, and the thing that's really unique about it is that it is very effective at absorbing UV radiation. This is the short range radiation, UVB here, and absorbs it very nicely. And that's a good thing, because otherwise we would have very bad problems with every time you went out in the sun. You would be irradiated, and that's a bad thing. So it has nothing to do with pollutants. It certainly has nothing to do with thunderstorms. Now, the unique smell of a thunderstorm is actually ozone, and is caused by the electrical discharge, lightning and stuff like that. And that forms ozone, but the ozone in the ozone layer absorbs the UV radiation. Aluminum is a group 3 element. Remember, our groups go across the top. Group 3 is right here. And aluminum is one of the metals in group 3. Remember, because it's a metal, it's going to ionize. So this is wrong. It's going to ionize, and the group number gives you the common charge for these simple elements. Therefore, since it's in group 3, this is going to be a +3 cation. Any questions? Significant figures, remember those. We have 2 rules that we have to remember for significant figures. First thing you do is look to see if your number has a decimal point. Well, it does. If it has a decimal point, all of the leading zeros are not real. They go away. But all the trailing zeros stay there. So this has a decimal point. Leading zeros, these guys are not real, they don't count, but the trailing zero here does. Therefore, this number has 1, 2, 3, 4, 5 significant figures. Now this guy doesn't have a decimal point. It does have a 0, but the 0 is surrounded by non-zero digits. If it did have trailing zeros, because it does not have a decimal point, if it had trailing zeros, those would not be real. Okay? Well, it has no decimal point. Trailing zeros would not be significant. And this 0 is between non-zero digits. So it is significant. So once again, this thing has 1, 2, 3, 4, 5 significant figures. All right, here we want to express 120,000 meters in scientific notation. When we look at our number here, remember to go to, well, this isn't 120,000, I'm sorry. We have all these zeros in front, don't we? Once again, significant figures, these would not be significant, but all the trailing zeros would be. Okay? So this is our number. In order to convert it to scientific notation, we need to move the decimal so it's after the first non-zero digit. So we're going to move it 3 places, and we're going to the right. That means it's going to be a negative exponent. Because we have 1, 2, 3, 4, 5, 6 significant figures, remember in scientific notation, you have to show all of the significant figures in your number. All of them. Therefore, this is the proper way to show this. 1.20000 times 10 to the minus 3. Minus 3 comes from moving our decimal over 3 places. But again, we have to show all of the significant figures in our answer. Any questions? All right, remember physical and chemical changes from way, way, way long time ago. What do we remember about them? A change in state is a typical example of a physical change. Yeah, actually, that's true, isn't it? We take ice and we melt it, we make water. That's a physical change. If it starts off water, H2O, ends up H2O. Physical changes are essentially irreversible. Well, of course, that's nonsense, because we could take our water and freeze it back and make ice again. In the physical change, the chemical makeup of the substance never changes. That's true. As we said, with ice and water, we start off with H2O, we wind up with H2O. Just one is solid, one is liquid, same substance. So both A and C look like they work, and that is the correct answer. All right, what's true regarding the electronic structure of a neutral lithium atom? Now, when we speak of electronic structure, we're talking about the electrons around the atom and where they are. Remember, we have orbitals, and we fill these orbitals 2 at a time, blah, blah, blah. First thing is to do is look at our periodic table. We want to find lithium. Lithium is right here. It's in the second period. Now, if we remember electron configuration, the elements in groups 1 and 2, or these groups 1 and 2, represent electrons that go into s orbitals. This would be 1s, 2s, 3s, 4s, etc., etc. Over here, this block right here represents electrons going into p orbitals. One exception, of course, is helium. First period only can have 2 electrons. So, lithium is in our second period. That means we put 1 electron, 2 electrons, and 3 electrons. We filled up the 1s, have 1 electron in the 2s. So, all the electrons are in the 1s orbital? No. We filled the 1s, and we have 1 extra electron. Total of 3 electrons in s orbitals? Yes. It has 2 in the 1s and 1 in the 2s. Because it's in the second period, it have at least 1 electron in a p orbital? No. Remember, p orbitals are over on the far right. And whatever. So B is the only correct answer. Any questions? All right, we did physical change. Let's do chemical change. Remember, a chemical change simply describes a chemical reaction. Okay, that's what we're doing in a chemical change. It's just a description of a chemical reaction. Chemical changes are always accompanied by a change in state? No. Anytime, actually, that you see the word always, it's always wrong. Just remember that one. Chemical changes are easily reversed by altering the temperature of the system. Well, that's silly. They always produce a new substance. Yes, because, again, we're describing a chemical reaction. In a chemical reaction, you start with one substance and you wind up with another. This is our correct answer, C only. Any questions? All right, Earth science. We're talking about crustal plates. Remember, there are crustal plates everywhere. And when one of them moves under an adjacent plate, is it called tectonic suction, subduction, eruption, or disruption? Well, this is an example. We have an oceanic crust here diving down underneath a continental crust. Oceanic crust, remember, is much denser, and so it can easily dive down, and this process is called subduction. As it dives down, this generates lots of heat here at the border where the two crusts are rubbing against each other, and that generates molten rock, volcanoes, mountains, and stuff like that. So our proper answer here is subduction. The original large landmass on Earth before plate tectonics formed our continents. What was that guy called? It was a P word, wasn't it? But it wasn't Panama. Pangea is what it was called. And remember, all the continents were a part of, basically part of one large land mass. As the mantle dwellings started, these started to split up. And as they split up, they generated the continents as we know them today. There goes North America, there's Antarctica there, Australia, and here's our favorite India, South America, Africa. India slams into Asia and makes the Himalayas. So, the original was Pangea. Any questions? All right, we saw an oceanic plate and a crustal plate. When two oceanic plates rub against each other, so this is in the middle of the water, what's going to happen? Well, just like the other thing, we have two oceanic plates. They're going to rub together. As one dives down, it generates lots and lots of heat, and that causes volcanoes. Because we're in the middle of the ocean, the eruptions build and build and build, and finally we wind up with a chain of islands. So our choices here were island building, subduction, volcanic activity. All of those are what happens. The subduction causes the heat causes the volcanic activity, and the volcanic activity leads to islands. All right, remember molar mass. Molar mass is simply the mass in grams divided by the number of moles. In this little table, we are given a molar mass of 228 grams per mole. We are told that this represents 0.1 moles, and we want to know what mass that is. Molar mass is simply mass divided by moles, that's grams per mole. Here we're solving for mass, and that's simply going to be moles multiplied by molar mass. When you do that, it's about 23.7. On your final exam, remember you get to bring a 3x5 card. So if you forget some of these little things, just jot them down on your little card. The mantle is down underneath, the crust is what's on top. We talked about that. Some places on Earth, not many, the mantle actually forms outcroppings, so you can see it. The two differ because crust contains enhanced concentrations of radioactive nonmetals, contains toxic heavy metals, mostly silicon salts, or iron manganese alloy. This is the image that we looked at. This is actually a crustal, or I'm sorry, a mantle outcropping. You'll note that it's not a very lush place to live. That's because it is actually full of heavy metals. Now, if you want to mine heavy metals, lead, gold, silver, stuff like that, mercury, this is a fine place to do it, but the concentrations are so high that basically it's toxic to anyone and most plant life as well. So, mantle contains a concentration of toxic heavy metals. The first one, radioactive nonmetals, that really doesn't make much sense. Silicon salts, silicon salts. Remember, the crust is very rich in silicon, and the core is the liquid iron manganese alloys. Greenhouse gases, remember those? Well, selectively absorb green light, absorb and re-radiate infrared radiation, absorb the UVA radiation, absorb CO2, or ozone. What we did about greenhouse gases, we just looked at this little picture. Basically, visible light from the sun comes down and hits the earth, warms it up. Now, in the absence of, quote, greenhouse gases, this would simply be radiated back into space, some of it. So we warm up the earth, and this just is radiated away. If we have, quote, greenhouse gases present, however, some of this infrared radiation coming from the earth is absorbed by these gases. When it does, they heat up and they radiate the heat back towards the earth. So instead of escaping, some of this heat comes back towards the earth. That causes the layer of the atmosphere here to warm. The more greenhouse gases you have, the more this effect will occur. So this causes the Earth's surface and lower atmosphere to warm. And this is our correct answer. Does not absorb green light, doesn't absorb UVA, CO2, or ozone. It simply re-radiates the infrared radiation. Which compounds will the cation have a +1 charge? Well, the simplest way to do this is to just look at your periodic table. Calcium is a group 2 metal, therefore it will have a +2 charge. Magnesium is also a +2 because it's a group 2 metal. Aluminum, we've already done this, this is a group 3 metal. Phosphorus trichloride, well, that's a molecular compound, isn't it? So it doesn't have a charge anywhere. It's just covalent. Ammonium carbonate. Ammonium, if you recall, is our polyatomic ion, the only one we talked about really, and it has a +1 charge. Yeah?
Now, I'm kind of confused. I forgot how the charges go. You know,
Okay, well, remember our groups here, group 1, 2, then we go to here, 3, 4, 5, 6, 7, 8. They're actually 18, but the group 1B, actually, these guys correlate very nicely with charges. Now, when you're looking at metals, we do +1, +2, +3. Over here, we could do +4. This end, we have nonmetals, and those form covalent compounds. Okay? These are our pluses. Over here, we would want minuses. This would be -1, -2, -3, and actually -4. So pluses and then minuses. All right, we're back to our gas laws. Remember, Boyle's law describes pressure and volume. Very simple. Pressure goes up, volume goes down. It's called an inverse relationship, right? So here, our pressure is going to decrease. What happens? Well, Boyle's law tells us that we have an inverse relationship. If the pressure decreases, the volume must increase. We also have a law called Charles's law. Charles's law, remember, describes temperature and volume. Charles's law is a direct relationship. Temperature goes up, volume goes up. All right, here we say we have increased our temperature. Therefore, according to Charles's law, as long as the pressure remains constant, the volume must also increase. What is density? Physical property, chemical property, allotropic property, a property that undergoes rapid change in response to gamma radiation. Well, this is certainly silly, isn't it? And I'm not even sure what an allotropic property is, but, sounded neat. But, so is it physical or is it chemical? Remember, a chemical property describes, again, a chemical reaction. Density is just something that is. It just describes the material. It is a simple, classic physical property. Boyle's law states that volume and pressure are inversely proportional. Which of these is Boyle's law? Well, when we say we have an inverse proportionality, what we're really saying is that volume is proportional to 1 over P. That's an inverse relationship. If pressure goes up, volume goes down. Now the thing we did with the gas laws, well, we can do it with anything. Anytime you have this little proportionality sign, we said we could get rid of the proportionality sign simply by sticking in an equal sign and a constant. So we can say that volume is equal to some constant times 1 over P. So that's what we're working with here. Volume is equal to some constant times P? Nope, it's supposed to be 1 over P, isn't it? V1, P1, V2, P2, this is our two-state equation, isn't it? If we did the one state, it would be V1 equals 1 over P. So this is correct. P1 over V1, P2 over V2, no, that's not right. If we multiplied that out, this would be P1 V2, P2 V1. That's wrong. And finally, this has too many things in it. Clearly, this is our two-state Boyle's law expression. This is one of our favorite labs where we got to stick little things in a flame and watch the colors. Again, a very, very simple thing. The color arises not because it's the actual color of the element, not because we have a reaction with the flame or with CO2, but the metal atoms will absorb energy from the flame. When they do, their electrons are promoted to higher quantum levels. They're not stable up there, so they collapse back down. Now, since the periodic table is quantized, this drop represents a discrete amount of energy. That generates wavelength or light of a single wavelength. You raise up 3 steps, then you drop down 3 steps. And that drop represents a discrete wavelength of light. That's why we saw the little lines. Food and nutrition. What does BMI stand for? Basal metabolic index, body mass index, Broadmoor index, basal mass indicator. Well, BMI represents that. It's your body mass index. You can calculate it based on your height in inches divided by your weight. Let's see, weight is weight divided by height in inches squared, isn't it? Times 703 or something like that. Body mass index, and again, a body mass index over 30 is considered on the obese side. Below 18, you're starving to death. I have 4 sons, and they all have BMIs of about 18. My goodness. And they can eat anything and more they want. It's just astounding. All right, what's true regarding radioactive half-lives? Remember, when things undergo radioactive decay, there's stuff coming out of the nucleus, isn't there? There are really 3 things that come out. Alpha particles, beta particles, and gamma. Gamma ray is just a photon, so just a very short wavelength light, if you will. Alpha particle consists of 2 protons and 2 neutrons. A beta particle is basically an electron, but that electron comes from the nucleus. So we have a neutron, this neutral. It loses an electron out of this neutron, turning the neutron into a proton. Okay, now we remember that the number of protons describes what element we have, right? So if we're changing a number of protons, as in decay of uranium, we start off with 92 protons, wind up with 90. That's giving us a new element. This process, the half-life, basically describes how long it takes for half of a sample to do this. For some elements, it's very, very, very fast. For something like uranium, it takes billions of years. So let's look at our choices. Half-life describes the time it takes for half of initial mass to decay to form another element. Yes, it must form a new element because we're changing the number of protons. Half-life describes to form a different isotope with the same element. No, not the same element. Because again, we're changing the number of protons. And they can be as long as billions of years. That means that A and C are both correct answers. Any questions? Remember we did electrolytes. We took this cute little thingy here with the battery, we stuck it in solutions, and if it was, quote, an electrolyte, our little LEDs here would light up. We had both of them light up. That was a really strong electrolyte. So what in the world is causing this? In order to be a strong electrolyte, must form ions, must be acidic, must be molecular. Well, some molecular compounds can be strong electrolytes. Remember we did HCl solution? Hydrogen chloride is a molecular compound. But why is it a strong electrolyte? Because it splits into ions, hydronium and chloride. Must be acidic. Well, there are lots of things that are electrolytes that are not acidic. Sodium chloride, for example. It must form ions. Yes, that is the one thing. Whoops. Come on. It must form ions in solution. It can be molecular or ionic. But in order to conduct electricity, you need ions. Process that converts ozone into oxygen is photolysis, hydrolysis, protolysis, a free radical chain reaction, or aminolysis. Well, remember this is what happens when the old refrigerants got into the stratosphere where ozone lives. An example was Freon 11. Freon 11 is trichlorofluoromethane. This absorbs the light from up in the stratosphere, and we break this bond and form radicals. Chlorine radical is what then reacts with ozone. This recombines, splits again. We start with a chlorine radical, and we wind up with a chlorine radical. That means that once you make one chlorine radical, this is just going to recycle, and that's what makes it a chain reaction. So, destruction of ozone to make oxygen is a simple free radical chain reaction. Any question? Yeah. I'm sorry? Explain that again? Sure. I'd love to. I love explaining things. This is what was figured out to be destroying the ozone layer. Remember, the ozone layer has a big hole. It's over Antarctica right now. But if we had not stopped using these refrigerants, it probably would have spread over the whole world. Still may, we don't know. But the chemistry behind it all. Light interacts with these refrigerants. This is Freon 11. And it forms radicals. Basically, the light is absorbed and it just splits this bond. A free radical, a neutral element, just with one unpaired electron. What they found was that the chlorine radical that was formed reacts with ozone. When it does, it converts ozone to oxygen. So this is the destruction stage. The radical that's formed here then goes on and does another 2 sets of reactions. But the important point is that at the end of our second reaction here, we reform the chlorine radical. Now, we started with a chlorine radical, and we end up with a chlorine radical. That means that this guy can now go back and destroy another molecule of ozone. So it just cycles around and around and around. Once you make one radical, you can go many, many cycles here and just eat your ozone layer up. Again, it's called a free radical chain reaction. All right, remember pH. We are increasing from 5 to 7. What does this mean in terms of hydronium ion concentration? Remember, pH is a negative log of hydronium ion concentration. So, if we are at pH 5, that is the negative log of hydronium. The negative log here, this would be 10 to the minus 5 molar hydronium. At pH 7, we have 10 to the minus 7 molar hydronium. So we are starting, here's our equation, 10 to the minus pH is hydronium. So we are starting here at pH 5. That's 10 to the minus 5 molar. We're winding up at 10 to the minus 7 molar. This is smaller than that by a factor of 100. Every pH number that you change represents a factor of 10. That's what the logarithm tells us. Every number is a power of 10. Simple balancing here. A calcium carbide reacts with water to form acetylene gas. We all know organic chemistry now. We know that this is called ethyne. Acetylene, though. Acetylene is what you use in a welding torch. Burns very, very hot. This particular reaction is famous because this was, still is, the chemistry that goes on in a bag-type cannon. When we were children, we could buy these little cannons. You would put calcium carbide in it, a little bit of water, generate acetylene, and then you set it off with a spark. And it goes, wow, it was great fun. Well, this equation is not balanced, so let's think about that. It's not difficult. We look over here, we're going to start. We see we have one calcium here, one calcium there. Remember, we have to put ones in, so I have something to grade. We don't typically put those in, but we must put a 1 in here. So we're going to start off by putting a 1 to represent our 1 calcium on both sides. Now, we also have 2 carbons here. Look on this side. Oh my gosh, we have 2 carbons. So that's good. So carbon and calcium are both working. Our water. We have 2 hydrogens here. We have 2 in our acetylene, and we have 2 over here. So we have 4 hydrogens, only 2 on this side, so we need to stick a 2 in here. Now when we do that, that also gives us 2 oxygens, doesn't it? We made 1 acetylene, that's fine, but our 2 oxygens here also show up in our 2 oxygens in the hydroxide polyatomic ion. So we have 2 oxygens, 2 oxygens. That's all we had to do to balance it. In an alkane, remember organic chemistry again. Alkane, a simple hydrocarbon, contains only carbon and hydrogen. We said that the carbon atoms were going to be hybridized. They hybridize in such a way that we take one s orbital and three p's, put them together, and we make tetrahedral geometry. So, organic chemists might be bipolar, but organic compounds are not. They are sp3, and they are tetrahedral. This is methane, just to remind you. Again, this is tetrahedral geometry. All of our bond angles are the same, 109.5. Remember that number, that's important. And again, this is the tetrahedral geometry comes about because we combine or hybridize one s orbital and three p's to make our four bonding orbitals. Any questions? Amino acids. Amino acids contain amino group and a carboxylic acid. They can polymerize to peptides, building blocks of proteins, and form the backbone of DNA. We remember that amino acids look like this. This is just two amino acids. They have an amino group and a carboxylic acid. That's where the name comes from. So our first choice was correct. We can combine these things. Take the acid of one, the amino group of the other, combine them, splitting out of water. And what we do, we form an amide linkage. That's also referred to as a peptide bond. We do this with the other amino group here. We form a peptide. This is just 4 different amino acids, and they're all linked together by amide bonds. If we do this over and over again, we get a protein. Protein is just a long chain of amino acids, all hooked together by these amide bonds. However, DNA, our backbone is sugar and phosphate. The interior, we have the DNA bases, but there are no amino acids present. Therefore, from our choices, A, B, and C are correct. Amino group, carboxylic acid, they make peptides, they make proteins, but they are not present in RNA or DNA. Okay. In the space below, right, a pH value, if our pH is 5. Well, you could do this the hard way, or you could do it the easy way. The easy way is just to remember that pH plus pOH always sum together to give a value of 14. So if our pH is 5, our pOH must be 9. They always add together to make 14. Which of these is acidic? pH less than 7, OH equal hydronium, OH is greater than hydronium. Well, if hydroxide and hydronium are equal, that would be neutral water, wouldn't it? So that's a neutral solution. That is pH 7, neutral solution. If hydroxide is greater than hydronium, then we have a basic solution. Hydroxide is basic. Hydronium is acidic. If our pH is less than 7, then we have an acidic solution. The thing to remember is simply this. If pH is less than 7, it's acidic. If it's 7 exactly, it's neutral. If it's greater than 7, our solution is basic. Less than 7 is acidic, 7 is neutral, greater than 7 is basic. When we talked about food and nutrition, we talked about BMI, and we also talked about BMR. BMR is basal metabolic rate. This is how much energy it takes just to live, just to sit and breathe and have your heartbeat. You can convert this into your daily calorie requirement, but this is going to depend upon how active you are as to how much energy you burn aside from just breathing and having your heartbeat. So, need to multiply it by a factor, multiply it by 703, no. Divide BMR by BMI, that would be silly. And it's not related, well, of course, that's wrong. We have to multiply it by this factor. Again, the factors depend upon how much activity you do. More activity, the larger your metabolic requirement. Any questions? All right, back to our gas laws. Here we are calculating an unknown parameter in a single state gas law problem. Remember, we had two sets of equations. One was a single state where you're just calculating an unknown, and the other was a two-state where we started here, changed something, and wound up here. For a single state, we said we would always use PV equals nRT. Now, conveniently, that's our first choice, isn't it? P1, V1, P2, well, this isn't even that. This is not even Boyle's law, is it? That's wrong. Is this the same as this one? Quick, do the algebra in your head. We would multiply by RV, and we would get PT equals nRV. That's different than PV equals nRT. So no, this is not the same. The only correct answer is A. All right, remember sugar metabolism. We did, this was glycolysis. Sugars are very nice sources of energy. Glucose is a 6-carbon sugar. When we undergo glycolysis, we said that the 6-carbon sugar is split into 2 molecules of what's called pyruvic acid. We also take NAD plus and ADP, this is adenosine diphosphate, nicotinamide adenine dinucleotide, and we form high energy compounds. It's called a reduced nucleotide and ATP. ATP is the thing that runs your muscles. Every time you move a muscle, you're burning ATP. So, what happens in glycolysis? We start off with a 6-carbon sugar, make 3-carbon pyruvic acids, and we make high energy compounds. Therefore, during the process of glycolysis, 6-carbon is split into 2, that's correct. Carbon atoms are never converted to fat, that's not correct. Remember, we wind up with our end product is acetyl-CoA. And your body is very good at converting that into fat. During glycolysis, high energy compounds are formed, that's true. So we have two correct answers, A and C. Now this might seem like a strange question to put on exam, but I would just like to see what everybody would do with their own food pyramid. We talked about food and nutrition. We saw lots and lots of different pyramids. Remember, the stuff on the bottom is what you're supposed to consume most of. So just put on your own personal choice. It gets you a free 5 points, right? My choice, well, I would do the 6 martini lunch. But. And the last question on our sample final. Which is correct following fat metabolism? That's also called lipid metabolism. This is the process of beta oxidation. Beta oxidation, we're going to take fats, break them down into little units. So our choices here, we're going to break it into 2 carbon units. Once our fat are absorbed by adipocytes, remember that's the cell that stores the fat. It's irreversible. Saturated fats are not metabolized. What we looked at was this simple reaction. This is a CoA derivative of a simple fatty acid called an acyl-CoA. So this is where your fat starts. It reacts with CoA. We make high energy compounds. Here we convert this into an unsaturated fatty acid. Note, you start with a saturated fatty acid, make an unsaturated. The unsaturated fatty acid is then split. Well, first it's hydroxylated. Then it's split into our friend here, acetyl-CoA. The rest of this is still strung on there. That's the R group. And the process just goes over and over and over again. We start off with a long chain fatty acid, and we convert it to the 2 carbon units of acetyl-CoA. Acetyl-CoA can be used to make sugar. You can go backwards through glycolysis. You can also use it to make proteins. You can also take it back and make fats from it. Very versatile, universal intermediate. So our question, during the beta oxidation, we're split into 2 carbon units. Yeah, we are. Once they're absorbed, they are stored indefinitely. Nope, it might seem that way sometimes, but fats move out of adipocytes very, very easily. Saturated fats cannot be metabolized. That's wrong, of course. Saturated fats have been vilified by the government. That's wrong, bad science. Beta oxidation works best with saturated fatty acids. Our only correct answer here is A. All right, so that took us just about an hour, and I talked most of the time. You should have no problem completing the exam in the 2-hour block we have. Remember, the exam is Monday. It will be at noon, right here. Please make sure to remember that to bring a calculator. I don't have a calculator to loan you. All tutorials and online assignments are back up. You can do your tutorial options, collect extra credit, and at the same time to help you study for the final exam. Make sure that all your labs are done, all the quizzes, the extra credits that's there. Make sure you get the most points you can. Friday at midnight, it's all over. All right? Yes, oh, yes, that's, yeah, make sure you put your name on your exam and hand it in. and that's 10 points extra.